All right, so back, I guess it was unit 3, we spent quite a bit of time learning how to factor, and then we moved on and learned some other things. Well, we're going back to factoring today, and so these first 2 blocks are stuff that we had already learned, but we're just going to go back over it like you forgot it. And then the next, or all the rest of it, is going to be new stuff in terms of factoring. So this is going to be topic 5.2, Factoring Polynomials. The first time that we factored quadratics. So on those, the largest exponent was typically a 2. On these, it could be really anything. So let's start with the GCF. So GCF stands for greatest common factor. So if we're looking at number 1 and we're looking at 12 and 10, what is the greatest number that divides evenly into those? 2. Good. So we're going to factor out a 2. And then if you look at them, they both have variables. So we are going to factor out an a. Do you guys remember what exponent we use? Anybody? All right, it's going to be the smallest exponent. All right, so we look at our exponents. The smallest one is 2, so we're going to factor out 2a squared. And when you're factoring out a GCF, you're basically dividing by it. So the 12, we're going to divide by 2 and get 6. And then when I divide x cubed by x squared, you're going to subtract the exponents. And that leaves you with a to the first, or just a. All right. And then the second term, I'm going to take 10. I'm going to divide it by 2. I'm going to get 5. And then what happens to the a's? They do cancel out. And that's it. That's all we do. All right, now I'm going to have you guys try number 2. It is a little bit more difficult. It's okay. Do what you can do. And then if you mess something up, it's okay. We'll fix it in just a second. Try to figure out number 2 on your phone. All right, so we're looking at 14 and 7. So the number they have in common is going to be 7. Right, and then they both have m's and they both have n's. So we are going to factor out mn. And then for each of those, we're going to pick the smallest exponent to factor out. All right. So then we're going to take 14, divide it by 7, that's 2. And then m to the 8th divided by m squared means we're just going to subtract 2 from that 8, and we'll get m to the 6th. All right, and then for the, for the n's, we're going to subtract 2 from that 5, and it'll be n cubed. All right, then I'm going to bring over the minus. I'm going to divide 7 by 7. That's going to be 1. And then what happens with the m and the n? Cancel out. And that's it. Great. So if you can do ones like number 2, I think you can do any of the greatest common factor ones. They don't really get much more difficult than number 2 does. All right, let's look at number 3. So very similar. We have 18 and 28. What can we factor out of 18 and 28? It's pretty small. Yeah, it's just 2. 3 doesn't divide into 28. 4 does, yeah. All right, and then we have p to the, we'll take the smallest exponent, which is 6, and then q to the third. I don't really like problems with p's and q's because they look so similar that sometimes my brain gets glitchy and I think that they're the same variable. But anyway, we're going to take 18 and divide it by 2, get 9. And then for the p's, I'll take 8 and subtract 6 from it, so that'd be p squared. And then in this case, q to the third is going to cancel out q to the third completely. All right, and then 28 divided by 2 is 14. And if we look at the p's, they cancel out completely. And then the q's, we'll take 5, subtract 3, and it'd be q squared. All right. Now you guys try 4 on your own, please, or we're going to move on to something different. The last one, it was q to the 5th factor, and you factored out q to the 3rd, so you subtract 5 minus 3.
What if there was Q5 and Q3, you just get rid of Q? I think they were swapped.
Well, if they were swapped, you couldn't do it, because you always factor out the smallest exponent.
Yes, we'll get rid of Q.
Okay, so looking at 16, 12, and 32, 4 is what we're going to cancel out. And then we take the smallest exponent for the x and the y, which in this case is going to be a 1. Just factor them out. Okay, so what questions do you guys have on factoring out GCF? All right, the next thing we're going to do is factor the difference of squares. And so to do that, we're going to make a list of perfect squares. I'm going to let everyone get that fixed for number 4. All right, so we've made this list a few times this year. I'm just going to go from 1 squared to 13 squared. I think that'll be good for what we are going to do for these lessons. And you guys can recreate this list anytime you want to with your calculator. Just start with 1 and just square the next number. All right, and then over on the side, I'm going to write some perfect squares that are variables, so that are x's. So x squared is a perfect square. X to the 4th, x to the 6th, x to the 8th, x to the 10th. So pretty much any variable that has an even exponent is a perfect square. And if we want to find the square root of a variable, you're going to divide the exponent by 2. So the square root of x squared, divide the exponent by 2, we get 1. So it's just x. The square root of x to the 4th is x squared. The square root of x to the 6th, we're just going to divide 6 by 2, and we get x to the 3rd. Okay, so back in the quadratics lessons, we did complete difference of squares. And so you may remember the rule. So if we have a squared minus b squared, so two perfect squares subtracted from each other, to factor it, we do those two parentheses, and then we find each square root, which is going to be a and b, and then we do one with a plus and we do one with a minus. So there's really not like trying things to figure it out. You just, if you can remember the rule, find each square root, and then you just kind of fill it in and you're done. Okay. And then if we want to do that on number 5, m squared minus 25. M squared is a perfect square because it's pretty much the same as x squared. 25 is in my list right there, so it's also a perfect square. So we can do this little shortcut factoring, where we'll find each square root, which is going to be m and 5, and do one with a plus and one with a minus, and then you're done. Right? You guys try number 6. It is a little bit more difficult, but like I said, if we mess something up, we can go back and fix it. So we want to find each square root, and then do one with a plus and one with a minus. All right, so 9 and 49 are both in our list of perfect squares. X squared and y squared are pretty much this right here. So this one is, we can do the shortcut, where we'll find each square root. So it's going to be 3x and then 7y. So that second y might have thrown you off a little bit. And then do one with a plus and one with a minus. All right. Now, number 7, if you look, 5 and 80 are not in my list of perfect squares. So what do you think we need to do first? We're going to factor out a GCF. So probably today and tomorrow, if it won't follow a rule, there's a GCF, and so we can just factor that out. So what divides evenly into 5 and 80? 10 doesn't go into 5. That's okay. Okay.
So it'll just be
It would just be 5. Good. So we're going to factor out of 5. All right, and that's going to give us r squared minus 16s squared. Now that 5 is just going to hang out on the outside. All right, now r squared is a square, just like x squared is, and then 16 is in our list. So we can just find each square root, which is going to be r. And then for 16s squared, it's going to be 4s and 4s. And then one with a plus and one with a minus. All right, I'm going to have you guys try 8. It's a little bit more difficult than 7. Factor out a common factor first on this one, just like we did on 7. So we're looking for something that divides evenly into 72 and 2. It's not 1. So what do y'all think?
2.
Just 2, yeah. So that'll be 36c to the 4th minus 1. All right, so 36 and 1 are in the list, and c to the 4th is basically the same as x to the 4th. So we can use our shortcut to do this. So we're just going to find each square root, which will be 6c squared and 1. And then do one with a plus and one with a minus. All right, and then number 9, it's got a lot going on because it's got the m's and the n's and kinds of stuff. So if we're looking at 7 and 28, do they have a common factor? They do. It's 7. So that yellow sheet that I gave you last time we did factoring, sometime in the next few days, try and find it because it definitely helps. It helps with the factoring we're going to do a few days from now, but it also helps with finding a GCF. You can just look in the 7 box, look in the 28 box, and see the biggest number they have in common, which is going to be 7. All right, and they both have an m. M to the first power is going to be the smallest exponent, and they both have an n, and n to the first power is going to be the smallest exponent. So then when I factor m out of n to the 7th, it'll be m to the 6th, and then 28 divided by 7 is 4. The m's cancel out, and then we'll have n to the 2nd. All right, m to the 6th is a square. It's in my square list over here, but written as x. That's fine. And then 4, obviously, is a square. It's in my list. So we can use our shortcut for this. Right, the square root of m to the 6th, we just take that 6, divide it by 2, it's going to be 3, so it's going to be m to the 3rd. And then the square root of 4n squared is going to be 2n. And we'll do one with a plus, and we'll do one with a minus. All right, you guys try 10. 10 also has a GCF to factor out first. 10 is kind of tricky, actually. So you're going to start off by factoring out a 10w. And then we have the difference of squares. And then to find the square root of w to the 4th, just divide that 4 by 2. So it'll be w squared. And then the square root of 1 is 1. And we do one with a plus, and we do one with a minus. Now, that wasn't super tricky, but we're actually not 100% finished on this one. Because if you look at this is still the difference of squares. So this is one of those kind of weird ones that you have to factor 3 times. This doesn't come up a ton. So I'm still going to have my 10w and my w squared plus 1. But w squared minus 1, I can do it again. So I can find each square root and do one with a plus and one with a minus. So make sure you guys are filling these in. So like I said before, your grade for today, it'll be a while before you get it, but it's just, you get a grade just for filling in all your notes. Okay, now I thought I was going to get through number 22 today. We're not going to. It's okay. We'll pick back up tomorrow, but I think we should be able to get through 16 today. So starting with number 11, this is a new rule that you guys have never learned before. And so there's 2 new rules that we're going to do, the sum of cubes and the difference of cubes. So for those, we do need to know some perfect cubes. And so if you want to create a list of perfect cubes, you can do it with your calculator. So you just take 1 and cube it. 1 cubed is 1. Take 2 and cube it. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. There's more, but I think that's as far as we'll need to get for what we're going to do the next few days. All right, so whenever you're doing these types of factoring and you think it might be the cubes, just make sure you're in that list. All right, variables are also perfect cubes. So x cubed is a perfect cube. And then any time that the exponent is a multiple of 3 is a perfect cube. So x cubed, x to the 6th, x to the 9th, x to the 12th, x to the 15th. We could keep going, just multiplying by 3 on that power each time. And then if we want to find the cube root of a variable, what do you think you divide by? Like the last one, we divided by 2, divide by 3. So just divide the exponent by 3. So the cube root of x cubed is just x. X to the 6th is x squared. X to the 9th is x cubed. We're just dividing those exponents by 3. Now, if it's a number and you want to find the cube root, and what I do is I just count. So, like if my number was 64, I want to find the cube root. I know this is 1, 2, 3, 4. So that's what I do. But if you want to use your calculator to do it, there is a cube root in the calculator. You hit for the cube root in the calculator, you hit math, and then number 4. And it'll do the cube root of whatever number you type in. Okay, so let me give you the rule for the sum of cubes. So if we have a cubed plus b cubed, you're going to do a small set of parentheses for a binomial and then a large set for a trinomial. Okay. So first thing you'll do is find the cube root of each of those, and then you put them in the small set and you bring over the plus sign. So the small set is just a plus b. All right. And then for the second set, you're going to square a, and then you're going to change the sign. So if it's a plus, we're going to change it to a minus, and then multiply a and b together. And then the last sign is always a plus sign, and then you're going to square b. So the first thing I do on these problems is I just figure out what a and b are, and I write it down. So on number 11, a is going to be whatever the cube root of x cubed is, which is just going to be x. And b is the cube root of 27. 27 is in my list. So you can type in the cube root of 27 in your calculator, or you can do 1, 2, 3. So the cube root of 27 is 3. All right, and then I'm just going to go in my formula, and then for a, I'm going to put x, and then for b, I'm going to put 3. So I would just bring up x plus 3 because it's a plus b. Right, then I'm going to square a, so that's x squared. I'm going to change the sign, so it's going to be minus. Then I'm going to multiply these together. So when you multiply a times b, it's going to be 3x. And then the last sign is always a plus. And then I'm going to square 3. What's 3 squared? 9. And that's it. All right. All right, why don't you guys try 12, or at least on 12, figure out what a and b are on your own, please. And if you feel like you're ready to plug it in, you can plug it in. All right, so I saw a couple of people make the same mistakes. So I just want to talk about it real quick. So when you're figuring out A and B, this is A cubed. So we want to find the cube root of 8. So that's just going to be 2. And then the cube root of W cubed is W. And then the cube root of 1 is 1. So the only time that this is actually exactly the same is when it's a 1. If it's anything else, it's going to change. All right, then we'll do our small set of parentheses and our big set. And then we're just going to fill in A and B. Let's see if I can make it fit on one screen. There we go. All right, so the small set, we just take A and add B to it. So 2W plus 1. And then in the big set, I need to square 2W. So I need to square 2, and I need to square W. That's a common mistake that people make is they don't square them both. All right, then we're going to change the sign and multiply them together. So 2W times 1 is 2W. Right? And then the last sign is going to be a plus sign. And then I'm going to square 1. And when I square 1, it's just 1. And that's it. So the difficult part of this is learning the formula, like memorizing the formula. But we'll do it a lot. It's kind of a long formula to remember. And I don't have a song to help you remember it. I could try to find one. All right, let's look at the next one. Okay, so when I look at this one, I do see that 216 is in my list of cubes. And m cubed and n cubed are basically the same as x cubed. So this is going to be the sum of cubes. Right? A is the cube root of m cubed, which is just going to be m. Right? For 216, you have two options. You can type it in the calculator, math, and then number 4, and type 216. Or you can, if you made your list, this is 1, 2, 3, 4, 5, 6. So the cube root of 216 should be 6, as long as your list is right. And then the cube root of n cubed is just n. Right, and then we have small set, big set. The small set is just a plus b, so you just bring these up with the plus sign. All right, then we're going to square m, which is m squared. Change the sign. Multiply these together, which I would write it as 6mn. The last sign is a plus sign. And then we're going to square 6n, which means we're going to square 6. And we're going to square n. And that's it. All right, you guys try 14 on your own. Oh, that's wrong. No, that's right. Sorry. I wrote it wrong on my sheet. Okay, so we'll start off and just bring those up in the parentheses with a plus. And then square 7p, so square 7 and square p. Change the sign, multiply them together. The last sign is a plus. And then square 4 and q. Okay. So we are pretty much out of time. We'll pick back up with number 15 tomorrow.